Hi everybody. Today you should get a blank piece of paper, or get the notes, I should say, the blank notes, so that you can have some place to fill these in. Today we're going to connect the imaginaries with the polars. So we did them separately the other day on Friday, and today we're going to put them together. So if you take a look at this picture, we just have the normal imaginary axis running up and down, and then of course the real axis running left and right with just a plain old right triangle. So they're asking you to express r in terms of a and b. Well, this forms a right angle here in the corner, and so we know that Pythagorean theorem, or by the fact of the definition of magnitude, or the definition of the absolute value for the complex numbers, all the same thing, that if you take a squared plus b squared and then take the square root of that answer, that will give you the length of r. So that's how you find r. Remember, your polar coordinates are r, comma, theta. That's what makes polar. This is polar. Anything rectangular feels more like left, right, up, and down. You're not traveling in a circle. You're traveling left or right and then up or down. Polar, you definitely are traveling in a circle to find where you're supposed to graph it. So now for number 2, it says use trig, and by trig we mean SOHCAHTOA, to express a, which is of course the real portion that's on that real axis. And we're only allowed to use r and theta. Now if you think about a and theta and r, a is adjacent and r is hypotenuse. Adjacent and hypotenuse, So that's cosine. And so the cosine of theta is equal to a over r. But the directions say to write an expression for a. So if we cross multiply, we get a equals r cosine theta. This already sort of starts feeling like polar. R cosine theta, r sine theta. So we're going to do the same thing for b. b is the opposite, and so this is going to be sine of theta equals b over r. And again, if we cross multiply, we get b equals r sine theta. When we think about a plus bi, and now if you just plug in what you know, right? A isn't a anymore. A is now r cosine theta. So z equals r cosine theta. I just said it's not a. R cosine theta plus b is now this, r sine theta. And then we have that I at the end. I usually comes at the end of the problem. They both have an r in common, so I'm going to factor that out. So we are left with cosine theta plus, and for emphasis, we don't want the angle to be associated with an imaginary number. You wouldn't find the sine of 25i degrees. That's not a thing. So we're going to bring out the I just for clarity, just for emphasis, to show that it's not part of the angle. I is going to come all the way out in front of the word sine, and that's going to be the theta. So the fact that these are the same, theta and theta symbol, meaning they're going to be the exact same angle. This is how we're going to write a polar number. So you have your complex number, that's a plus bi, and now we have this polar number, which is r times cosine theta plus I sine theta. So to show you how we do this, we're going to put this in polar form. Well, polar form needs r and theta. Just like when you graph it, it's the same thing. So we're not graphing it, but we're writing the form. Or the form of the polar form. So we need r. R is problem number 1, and you can see that the definition of r, or how you find r, is the square root of a squared plus b squared. Now, that's supposed to be 3i, not capital I. Always make sure you drop the negative, because if you're going to use the calculator is wrong. Get rid of the I, because I squared is -1, and then when we squared that again, it turns into +1, so it's not going to impact the answer. So this is the square root of 49 plus 9. We like to keep this a radical rather than a decimal, because radical is the exact answer. We don't really have a choice with the angle. We have to use a decimal. We're going to go to 3 decimal places. And so we know that the tangent of this angle is equal to, -3/7. Pay attention to the quadrant that this angle is in. If we are to the right 7 and down 3, we're in the 4th quadrant. So put it in the correct quadrant, and we get 336.8 1 degrees. I guess we're going to go to 2 decimal places. That's all I have written down. So the square root of 58, and then inside here we do the cosine of 336.81 plus I sine of 336.81. That's how you write the angle, or I'm sorry, the polar form of that number. Now, number 6, I just sort of stuck in here because I kind of forgot to show it to you on Friday. My fault. So apologize for that. But this is how you find the difference between two complex numbers. You find the absolute value of their differences. So you want to subtract first and then do the absolute value, or find the magnitude, or find r like we just did. It's all the same thing. So we're going to subtract them first. 4 plus 2i minus negative 3 minus 5i. So 4 plus 2i plus 3 plus 5i. So when we subtract these, we're combined like terms, we get 7 plus 7i. That is not the answer. That is just z minus w. Now we have to find the absolute value of z minus w, which, as you know, is just the square root of a squared plus b squared, which is not b, of course. It's 7. I don't know why that's not the same color all of a sudden. It's weird. All right, so then we're going to have the square root of 49 plus 49. And this is going to lead you to 7 radical 2. Now, to multiply these numbers together, these polar numbers, it looks kind of crazy. But I have kind of the shortcut version written underneath there. So you're going to have, this is one number right here. And then this is your second number. So to multiply them, you multiply the radius, the 2 radii together, and then you add the angles. So the angles will still go in the same spot. It's still cosine and I sine. So to give you an example of this, if we're multiplying these two numbers together, you multiply the 2 radii together, keep everything in the same spot, cosine is still there, but then you're going to add the angles, 30 plus 45, 75, plus I sine of 75. That's as simple as it is to multiply. Multiply the numbers out front, add the angles together. Now, to put these back in rectangular form, so this is a polar form. We want it in rectangular form. They're both complex. It looks like distributive property. It is distributive property, essentially, but there's no comma in between. This is still a single number. And so we have 7 cosine of 150 plus 7i sine of 150. We need the exact values here. Decimals will not be accepted because of the unit circle. This is on the unit circle. So the cosine of 150 is in the second quadrant, so cosine is negative, radical 3 over 2. Plus 7i, I'll put that over 1. Sine is positive 1/2. This is a number. So it is negative 7 radical 3 over 2. Plus 7i over 2. And because this already has a common denominator, please combine them, writing it as a single numerator over a single denominator. So negative 7 radical 3 plus 7i, that whole thing is over 2. So just to try this one more time, again, distribute your 3 or your radius, 3 cosine 180 plus I sine 180. You take out the cosine and the 180, and in its spot you put in the number, which is negative 1, plus I. That's still I. Sine 180 is coming out, and the sign of that number is 0. Oops, forgot my 3. So 3 times 0 is 0, so this is just going to give you negative 3. On Friday, the last thing we did, or the first thing I did, I should say, was we talked about conjugates. And the conjugate of a number that is a complex number, if you recall. We graphed them. We said, oh, here's like vector z, and then the conjugate of vector z was in that fourth quadrant. The conjugate we also summarized by saying it was a reflection over the real axis. The real axis is the x-axis, this one. So we just flipped it over. So if we think about where the cosine over 48 degrees is, we want to find the conjugate of this number. So we want to reflect this over that x-axis. So 48 degrees would go up. So there's 48 degrees. To reflect it over the x-axis, we would just flip it down and call that negative 48 degrees. But we really want to have that as an angle that came from 0. So if you add 360, you get 312. For the conjugate, you don't change the length. You change the quadrant that it's in. So we've changed the quadrant by changing the angle. So the conjugate of the number in the directions would be 8, same radius, cosine of 312 plus I sine of 312. So the conjugate means just find the new angle, don't change anything else.